Okay, ladies and gentlemen, we're going to look at some applications of these quadratic equations. Okay, this is section 6.5. There are a handful, 5, 6 different styles of questions that you can expect. You've seen projectile motion problems in the last chapter, along with optimization and some other sort of maximizing area or volume, minimizing the amount of surface area. Those are all the optimization ones. Or maximizing your profits. That's when you raise the price by a certain amount, you lose a certain number of people maybe, or sell fewer items. What would give you the most profit? These are all modeled by quadratic functions. When we're dealing with quadratic equations, what we're specifically looking at is not the vertex, but the x-intercepts, okay? What we call the zeros, the solutions. And I'm going to look at a bunch of different questions right now. The first one being number problems, okay? What we do is we call that number x, okay? So the number that we're looking for is x. And it says 2 times the number, so 2x, plus 3 times the reciprocal, which is 1 over x, right? The reciprocal of x is 1 over x, equals 7. And in this case, or at this point, all you have to do is solve it algebraically. So 3 times 1 over x is 3 over x. You want to get rid of the denominator, you multiply everything by x. So boom, boom, boom. That gives me 2x squared plus 3 is equal to 7x. You now rearrange it so you get a quadratic equation, equate it to 0, and factor it. Boom. So 2x and x, right? Take a sec, see if you can figure it out. Minus 1 and minus 3 would be the answer. So 2x minus 1 is 0. X minus 3 is equal to 0. That gives me x is 1/2. That gives me x is 3. And you're done. You can check them if you want, put them in here, but I guarantee you those will work. All right? Let's look at another one. Projectile motion. We've done these, so I'm not going to go through the whole thing. This is a situation that's a little bit easier to solve because you don't have to complete the square or anything. You don't even have to use a quadratic formula. You could if you wanted. But what I did was I made the height 0, because what's happening is you're looking for when it hits that, if this is h and this is d, right, where it hits the x-axis. The height is 0. So you'll see that you don't have the last term. Hopefully you can see that you can factor out a d. It leaves you with minus 2d plus 0.5. This means that right away d is 0. That means that it starts on the ground, okay? The next one we look at is minus 2d plus 0.5 is equal to 0. So we can make them both positive. And then if you want to find the d value, it's 0.5 divided by 2, or 1/4. At first glance, that doesn't look like it makes a lot of sense. It says our d is in meters. What would probably happen? Say this is 1 meter, right? It just went straight up and then went straight down. So it only traveled a horizontal distance of 1/4 meter, okay? If you wanted to find the height, well, all we have to do is find the vertex by completing the square here and identifying the HK, right? So area problems, these are another one. It's geometry involving, I'm dealing with some rectangles. You might have to deal with some circles. I'll give you the formula for the surface area, for the area, for the perimeter. Any formulas you need, you will get, right? So here we go. First one is a uniform border around a pool. So the original dimensions, if you look at the question, are 3 by 10. If you want to put a uniform border all the way around, okay, it looks like this. So the area of the pool is 30, right? What you are adding all the way around, find the width of the border. Whenever you identify what you're looking for, that is x, okay? So x, 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 and x. So the next step would be to find the new dimensions. If the original was 10, that means that it's 2x bigger, and the width is also 2x bigger. Now you have length times width is equal to the new area right here. And you end up having a quadratic. Let's FOIL it out. 30 plus 6x plus 20x is equal to 78. Oh, sorry. I didn't finish that off. Sorry, 6x, 20x, and then plus 4x squared is equal to 78. Let's rearrange it. 4x squared, that gives me 26x minus 78 gives me minus 48 is equal to 0. Now we're in a situation where we need to solve this quadratic. You can start using the quadratic formula right away if you like, or you can factor, right? Maybe we should reduce it by 2 to make it easier for us. 2x squared plus 13x minus 24. Let's see if I can actually factor this now. 2x and x, 6 and 4, no, 8 and 3, it looks like. That doesn't make, that's a 2 there. Oops, can't read that. Let's make sure you can read it. 2x, so I have plus 16 minus 3 would give me the 13. So I've managed to factor it, which is a good thing, because now I look and I say, okay, well, 2x minus 3 is 0, and I say x plus 8 is equal to 0. This means that x is equal to 3 halves, and x is equal to negative 8. Hopefully you can see that this one doesn't make sense. You can't have a negative 8 as an answer when you're talking about length. So the answer is 3 halves. So what would the new dimensions be? Well, 1 1/2, 1 1/2. It'll be 13 by 6, because this is 1.5, that's 1.5, that's 1.5, that's 1.5. So adding 3 and adding 3 gives you your new dimensions of 13 by 6. All right? Here we have a triangle situation, the hypotenuse of a right angle triangle. Boom, there we go, right angle. 20 centimeters is the hypotenuse. The sum of the other two legs is 28. Find the length of the other two sides. Find these lengths. That's what you're looking for. Call one x. The other one, well, you can call it y if you want, but they need to be the same variable. Let's look at how we can sort that out. They both add up to 28. That means that y is equal to 28 minus x. So instead of y here, we can put 28 minus x. Now, what relationship do you have between these three sides of a right angle triangle? It would be x squared plus 28 minus x squared is equal to 20 squared. We simply use Pythagoras, right? So x squared plus, let's look at this, 28 squared. I don't know what that is off the top of my head, so I have to try it too. 784. 784. Well, let's take this out of here. 28 minus x times 28 minus x, right? So boom, that's 784 minus 28x minus 28x plus x squared is equal to 400, which is 20 squared. Now we're on the right track here. We just have to simplify, right? 2x squared, let's get rid of those, minus 56x, that gets rid of those. 784 minus 400 is positive 384 equals 0. Again, reducing it would make it easier to solve. That's going to be, let's make sure, 384 divided by 2 gives me 192. Now, I don't necessarily have an easy way to factor this. You might want to factor it, but let's try the quadratic formula. A is 1, B is negative 28, and C is 192. So 28 plus or minus the square root of B squared. So 28 squared we already saw was 784 minus 4 times A, which is 1, times C, which is 192, all over 2 times 1. So I'm going to do the inside now. 784 minus 4 times 192. I end up with 16 on the inside. So this is going to be 28 plus or minus the square root of 16 all over 2. Now we know the square root of 16 is 4, so it's 28 plus or minus 4 over 2. Well, 28 plus 4 is 32, divided by 2 is 16. 28 minus 4 is 24, divided by 2 is 12. So if you call this one 12, let's look up here now. So if you call this 16, 28 minus 16 is 12. So let's put the numbers where they look like they might belong. Since this one's shorter, we'll call that one 12 and we'll call that one 16. Just so happens that these are both the legs, eh? Looks pretty cool. So now, distance, speed, and time problems, folks. Brett lives upriver, 40 miles. Okay, so these are where we make the tables, okay? With these, we need tables. So much easier. And this relationship of distance, speed, and time, hopefully you remember it. Okay, so it would look like, well, you have the pyramid here, or you can simply remember that the speed is kilometers per hour. Okay, that's another way to remember the relationship. So read the question. He's got 45 miles upstream, 45 miles downstream. It says the current is equal to 2. You're looking at his boat. That's what you're looking for, right? So now, upstream, downstream. It's like headwind or tailwind. Upstream is slower. It's the speed of the boat minus the current, okay? And downstream, if you're going with the current, it's the speed of the boat plus the current. Now, if you look at time here, okay, time is distance over speed. So 45 over x minus 2, 45 over x plus 2. This is a time upstream. This is a time downstream. What you have is a 14-hour round trip, which means that going downstream plus going upstream will equal 14 hours. And now we have a rational expression that we have to solve. Okay? And this rational expression has two denominators. You multiply everything by those two denominators, which means that the x plus 2's cancel. So on this side, you end up with 45 times x minus 2 plus 45 times x minus 2 is equal to 14 times x plus 2, x minus 2. So 45x minus 90 plus 45x, sorry, this one should be a plus 90 is equal to 14 times x squared minus 4. You get 90x, right? 45 plus 45. The 90s cancel each other out. That's all gone. So this is equal to 14x squared minus 56. Let's bring everything to one side. Minus 90x minus 56 equals 0. And at this point, you can solve it, okay? I'm not going to get into the solving of this. It's going to take too much time. You can reduce it if you like. You can factor it if you like. You can use the quadratic equation if you like. Right now, I'm just going to try and help you set it up, okay? That's the final quadratic we have. Let's look at another one. So we're almost done. We've got a few more here. James is driving to his parents that live 300 kilometers away. So he has to drive there, and he has to drive back. Since we're still dealing with distance, speed, and time, let's put those up there as well. What we see if you can take some of this information and plug it in there. Okay? So 300 is the distance in both directions. The speed is what we're looking for. So the speed there we'll call x, and the speed back is 10 kilometers an hour faster. Now we're on the same page, where the same situation where time is distance over speed. So 300 over x and 300 over x plus 10. So now, a little bit different this question because it doesn't give you the total time, but it does tell you, let's look at this. This is there and this is back. Okay? We're going to equate these somehow. It says that on the way back, he took 1 hour less. So this is actually one smaller. So if you want to make them equal, you can either add one here or you subtract one there. Either or. Okay? I don't really care which you do, but let's just put it plus 1 on this side. Now, I have a rational expression. You need to get rid of those denominators, so you multiply everything by that common denominator. In this case, the x is canceled. You end up with 300 times x plus 10. In this case, as the x plus 10's cancel, you end up with 300x is equal to, sorry, I'm getting this wrong here. We've got, where are we here? Equals 300x, and this is going to be both of those. So plus x squared plus 10x. Now you're almost there. 300x plus 3,000 is equal to 300 310x plus x squared. We'll leave the x squared on this side, right, because it's positive. So now 310x minus 300x is plus 10x, and then minus 3,000. Okay? What do we got here now? 60 and 50. Looks like it might work. Okay? So here we have x. I'm going to factor this one. I think it's going to work. Plus 60 and minus 50. And what we have then is x is equal to negative 60 and x is equal to 50. This is obviously the right answer since he's not driving backwards and you can't have a negative speed. So on the way there he drove at 50, on the way back he drove at 60, right? And it kind of makes sense, right? So if you actually figured out at 50 kilometers an hour, right, that would be 6 hours. And on the way back, that would be 5 hours. So that's an hour less. Perfect. All right, let's see what else we got here. Rate problems. Here we go. So, Bill's hose, okay, and the neighbor's hose. Let's make a table here. So, Bill's can do it in 12 hours, and his neighbors can do it in 15 hours. So this is alone, all right? Now this is where it gets a little confusing. You want to know how long it will take to fill the pool using both hoses. So both hoses is equal to x. That's time, hours, right? So think about it. If he's doing 12 hours, if you filled it up, if you're only doing Bill, and you had the hose there for 6 hours, that means he would have filled up half of it, right? 6 out of 12 after 4 hours. 4 out of 12. Okay, so 1/3 of the pool. So after X hours, right? After X hours, he's going to fill X 12ths of the pool. And similarly, his neighbor will fill in X 15ths of the pool. And together, they fill in 100%. So X over 12 plus X over 15 is equal to 1. Now you'll notice that this isn't actually a quadratic function when you solve it, okay? 12 and 15, well, let's just multiply this by 12 times 15, or 12 and 15, so that gives me 15x plus 12x is equal to, what's 12 times 15? 180. This ends up being a little bit easier, right? You get 17x is equal to 180. That's an easy one to solve. You just divide by 17. Okay, not a quadratic, but still helping us set up some of these questions. Hopefully this one will be a quadratic, and then we're done. Let's have a look. So we got Ramil and we got NC, two very odd names. So we always have alone and together. So Ramil takes 9 hours longer to construct a fence than it takes NC. How long would it take each working alone? So if we don't know NC, so it's called NC alone, and it takes Ramil 9 hours longer. So 9 hours longer is simply x plus 9, right? So together they can do it in 20 hours. 20 hours. So if you look at the previous question, right, the previous one, we showed, is it on the back here? We showed that together, both goes on top, alone goes on the bottom, right? So together goes on top, and alone goes on bottom. So 15 x plus 9ths, I guess, right? So it depends on how much time it takes each of them to do it. But what we end up having, again, is a total of 1. That's 100%, right? So after 15 hours, they've done 15 whatevers, how long it took them, right? Say it took them 20 hours, it'd be 15 20ths. Say it took them 11 hours, 50, well, it doesn't make sense. But anyways, hopefully you get the idea. In this case, what we do is we multiply by the common denominator. So you get 15x plus 15 over x, or times x plus 9 is equal to x squared plus 9x. So 15x plus 15x plus, that's 90, 135 is equal to x squared plus 9x. X squared That's 30x. Bring it to that side, minus 30x. So we get minus 21x minus 135 equal to 0. And you might be able to factor that. You might be able to solve it using the quadratic formula. I'm looking at 35. Well, let's have a look. So 135 divided by 9, 15. Is that going to give me what I want? 21? No. 135 divided by 13. No. So we're probably going to have to use a quadratic formula here, where your A is 1, your B is negative 21, and your C is negative 135. Okay. I don't know if that helped, folks. I know it was a little rushed. I hope that you might be able to make some sense of that it helps. If not, come talk to me and we'll sort it out, okay?